Section 3.1, Relations and Functions. We've talked informally about functions up until now, but now we will develop a strict definition of a function. So previously, we've talked about the black box metaphor, that when we have a function that we'll name f, we have an input that goes into the function, and we get an output out, which make up our order pairs x, y. And f can be anything. F could be 3 times x, f could be x divided by 2, f could be x plus 5. But the point is, f is defined so it does something to x and spits out an output y. We also have already talked about function notation, where for any given function, it has a name, an input, an output, and a rule. And the rule is what happens inside the black box. So we could make up a table of values where we plug in 0 for x, we get out 5 for y. So in our little box metaphor, we plug in a 0, we get out a 5. If we plug in a 1, we get out a 7. We plug in 2, we get out 9. And we see that pattern going on. The important part, and this is where we're going to start getting into a strict definition, is that a function is a relationship between two variables, the input and the output, where each input has one and only one output. So if I plug in x into my function, I should not get out 2 different y's. I should only ever get out a single output. This means kind of what I went over above, but also consider this. I can plug in 2 different x's to the same function, and it's alright if I get the same y. That's okay, because still we're seeing that each input has only one output. This will be easier to explain with an example. So in this first example, I want you to determine if what is given below is a function, and you will see this in equation, graph, and table form. First, we'll talk about graph. And for a graph, we want to try doing the vertical line test. So this first graph, if we take a vertical line, and if we carry it across the graph, we see that there are points when that line intersects 2 parts of the graph. This means it does not pass the vertical line test, and so it is not a function. And that's because if we plug in there we go. If we plug in, say, 1 for this function, if we were to plug in x, we could get either a positive 1 or a negative 1 as our outputs. Meaning that is why it's not a function. That's why it doesn't pass the vertical line test. We can try it with our second graph, where we see that as we run our line across the graph, the line only intersects the graph at one point at any given time. So for each x value, we only have one y value that corresponds to it, meaning that yes, this is a function. Next, we'll look at table form.